We are going to see few topics. Not much is left now because we had covered most of the topics till yesterday. So today's topics are going to be some more questions on sorting. Okay. Then second is we are going to study referential integrity, relationships between tables. And third, we are going to see simple SQL DDL commands using SQL tool. So we are going to see a few commands in SQL. We are going to see sorting and referential integrity. Okay. So these are the topics which we are going to discuss mainly today. So the first thing is sorting, right? So a few questions related to sorting. So let us see. Yesterday I had explained to you how to sort a table based on one field, two fields and three fields. And as we know that in a table we can sort at the same time. If we want to sort, we can sort a table based on maximum three fields at the same time, not more than three fields. And for that we saw some practical questions also, where we sorted the table based on the gender first, then within each gender category we sorted them based on the department, then within each department we sorted the names. Okay, so this way we have done the sorting up to three columns or three fields. Let us see one question today. So the question is, arrange all the, okay, let me first open. So I already have this opened over here. Just a second. So I have the table teacher over here, and on this table teacher, we are going to apply all the commands. So here we are going to sort it based on the date of joining. So I'm look at the query very carefully. Arrange all the teachers on the basis of ascending order of their date of joining. That means the most experienced teacher displayed at the top. Most experienced, and when we say most experienced, it implies that the person or the employee is the one who has joined earliest as compared to the other employees, and that person's date of joining will be at an earlier date. That means here we are going to sort a table based on which field, or the data type of field is what type. Means what will be the data type of that field? It would be date time or specifically date, and here the sorting order will be earliest to latest date. So this is how we are going to do the sorting. So let's go back. So here we are, this is the table, and over here you can see already the table is sorted based on some other order. Okay, we had already sorted it based on gender, then department, then name. So again, I'll go back to the sort dialog box, and from here I will first remove the others. So just in order to remove the sorting, just click on this drop down list and select none. Here you don't need to do anything. Why? Because already it will be either ascending or descending, and ascending is the default. So just we need to select that and click on none. Now we come back to the first field, and that is going to be what? Date of joining. And because it has to be earliest to latest date, that means order will be ascending. Click on OK, and you can see that Sandeep is the teacher who is the most experienced. Why? Because his date of joining is the year, you can see 96. 1996, and others they are 97, 98, 99, and so on. Okay, so this is how you can arrange date type data also. So we learned how to arrange date type, date field, numeric field, and textual field also. Okay, one question I'm giving you all. So now the next question is, arrange all the teachers based on highest to lowest salary, and then arrange them based on their age. And here age will be uh, oldest person first. So when I say oldest person first, it means what? Can anyone tell me? What do you understand by oldest person first? When I am saying you have to arrange all the teachers based on highest to lowest salary, and then arrange them based on their age, where oldest person has to be displayed at the top. It means what?
Ascending order of their date of birth.
Oldest person means the person whose age is the highest, that will be displayed first, right? Oldest means what? The person whose age is the highest. It means what? It will not be ascending there, it will be descending order. Okay, so we are first going to sort based on salary, and there it is highest to lowest means descending order, and second is going to be age, and here also it's going to be descending order. If you work out in your copy like this, it will be easy for you to do the sorting. So let's go back to the table here. So now first we go to, like, I can now I'm going to data and I'm selecting sort. You can also select it from this option. And the first option is the salary. Okay. So first I go to salary and select the order as descending. Then I select what? The second one is age, and that also has to be descending order, and click on OK. And now you can see that the salary is sorted in descending order, and based on salary, first salary will be sorted, and then within each salary category the age will be sorted. So here now you won't find much difference in, or you won't find any particular sorting order in age, because the first preference is always given to the first field. So salary field is over here, but you can see that there are two salaries which are equal, that is 30,000 and 30,000, and here the descending order is quite visible. You can see it over here, 50 and 32, right? Then we come to 25,000. There the age will remain as it is, 21,000 age as it is. Then 20,000, 20,000. Within this you can see descending order, first 33 and then 31. So the first field which is selected, once the table is sorted based on that, then within that, if any two or more records are there which have the same value for that field, the next sorting field, uh, the next sort field, the next sort order will be applied on that group, right? This is a bit difficult to understand, but if you do the practicals some 5 to 6 times, it will be clear to you, right? So you can
Ma'am,
see over here, yes.
ma'am, because of some network issue, hang up and rejoin the meeting.
Okay, dear, no problem. So you can see over here that 30,000, 30,000 is there. So here you can see the descending order is quite visible in these two, right? And here also descending order is quite visible, right? So this is how we sort a table based on different. That does our sorting. Okay. So now next is we are going to see referential integrity. So our sorting is done. Next is referential integrity. Now, what is referential integrity? So let us see a small PPT on this. I have prepared a small PPT. Students, referential integrity basically means that in a database, the main idea is to protect your data, to keep your data in a consistent state, such that if you are making any changes somewhere, if you are making any changes in one table, it should not be like the other tables are not affected. All the related tables, all the tables which are connected with this table should also be affected by this table. If I make any change in any value here, so accordingly that value should get changed everywhere, okay, wherever it is needed or wherever the table is connected. In order to understand this example, I will show you one very important thing. Please watch that very carefully. What is actually referential integrity? So there is a table here and we are going to understand that with the help of that table. Yes, take a very good look at this slide over here. Now in this slide, you can see there are two tables, table department and table employee. So two tables are there, department and employee. Department information is stored in DPT table and employee information is stored in employee table. Let us take a look at the columns of employee table. You have MPNO, e-name, some other columns might be there over here, okay, like address, age and everything. Those are immaterial here. Then salary, commission, some salaries, some employees, they get an extra incentive on doing some work which is based on performance, okay. So they get that incentive and that is known as commission, right? And then you have DPTNO, that is department number. And this department number field, as I have already explained, in the DPT table, department number is the primary key, and within the employee table, department number is the foreign key. As you can see, some duplicate values over here. So this particular field, which is a primary key in some other table, is being used in this table with duplicate values. This field depends on its parent table field, right? Each value in the department number column must match a value in the department number column in the department table. That means, can you find any department number which is not 20 and 30? You can see here only two departments are there, research and sales, okay, and their department numbers are 20 and 30. So here in this table also you can use only these values which are present in the DEPT table, not any other value. Okay. If you delete in any department, suppose if you delete department sales from table DEPT, automatically all the fields, all the records having department number 30 will be deleted from table M also. And in this case, those fields are going to be these. One is this one, that is Allen, and second is Ward. And one more, that is Jones. If you delete 30, that is sales, from the DEPT table, then those three records which have the DEPT NO as 30, they will also be deleted from employee table. That is, whatever you do in the parent table, it will have its consequences or it will influence its child table as well. So this is known as integrity. That is, एक जगह कुछ भी आप change करते हो तो दूसरी जगह पे उसका effect दिखना चाहिए. This is known as integrity. Now, how integrity is maintained? Integrity is maintained only by means of following or establishing relationships among the tables. So there are these types of relationships, basically three types of relationships as you can see over here. One-to-one relationship, one-to-many relationship, and many-to-many relationship. Let's see an example of each. These are examples of one-to-one relationship. Like you can see two tables are there, country and capital. And within country, you can see there is a field ID and name. And within capital, you have ID, name, and country ID, right? So now, students, we know that every country has exactly one capital. Okay, so that is why when these two tables are connected to each other by the ID field, the relationship is one to one. That is, no duplicate values will be there. One country can be connected to only one capital. Understood? So here the country ID will be there. Country ID is this ID. That is ID of the country table. So that, how do we understand? Okay, this country, it's the name of the capital and the capital ID. Got it? So this is how it is going to be connected. So it is one to one connection. Understood? That means one country can have only one capital. Coming to the next table, students table with contact info table. Here also, one student can have one contact. Although now here the thing could be like, suppose for example, the college has uh, kept a particular procedure or a protocol that only one contact number has to be assigned to one student, or one student will provide only one phone number. So here one student is like, these two tables are connected on the basis of one to one basis. One student, one phone number. Got it? So this is a one to one relationship. Coming to the next one to one relationship, you can again see two tables over here, company cars and employees. And here one car is allotted to only one employee. So you can see car ID is the primary key within company cars table, and it contains other information like license number, model year, make and model. Make is the manufacturer, the brand name and the model. Okay, which model of that particular brand. And in employees, you have employee ID, first name, last name, full name, address, city, state, and car ID. That is which car has been assigned to the employee. Now, company will assign only one car to an employee, and one car can be assigned to only one employee. That means it forms a one-to-one relationship. Next, one-to-many relationship. Now, here you can see a customers table, and here you see orders table. Now, one customer can place many orders, multiple orders, like I had explained it in the last class. So, one customer can be associated with multiple order IDs, as you can see over here. So, this is a one to many relationship. This side one and this side many. Many to one or one to many, they both are the same. One to many, another example, products and reviews. One product can have reviews by multiple customers, yes or no. You are also, suppose you saw an iPad and you posted your review for that iPad, okay, on the website, and somebody else also posted that. I also posted a review, and say 100 different customers posted their reviews for that product, but all of them are posting the review for one product only. Okay, so here it is a one to many relationship. One product, multiple reviews. Got it? So this is a one to many relationship. Next one, again another example of one to many. Country and UN representative. That is, every country, now one second, one country can have multiple representatives, right? So these are the names and details of the representatives, and these are the names of the countries. So this is also one to many relationship. Coming to the next, many to many relationship. You can see over here there are three tables: orders, order lines, and products. So in orders table, you can see there is a customer whose customer ID is 5678. He placed an order on 20th July, right? Now on 20th July, what all things did he purchase? You can see his ID here, the order date here, and three different UPC, that is Universal Product Code. Universal Product Code is the barcode which you have seen behind items, okay? And when you visit any nice retail outlet like Hyper City or any mall, okay, so there you see that the people who are there at the checkout stand, and what they have is a barcode scanner, and they just place the barcode scanner on top of the barcode. A laser beam is focused and that barcode is processed, okay? So these UPCs, they represent the different items. So you can see that one customer has placed an order for three items. So orders, one order, okay, three order lines, right? And one product, also three different, means one product can also be ordered by multiple people. So you can see this is a many to many relationship, okay? Many customers, one customer can place or purchase many items. You can see one customer can purchase many items, more than one items. I purchased a television also, I purchased a phone, I purchased a laptop. I as a customer can purchase multiple items, and the same laptop can be ordered by multiple customers. As you can see here, one this same order, this same product with this UPC is ordered by customer ID 5678 also, 9012 also, and 5678 also. So this could be some other name, like some other customer. We cannot have the same customer ID. This is okay, but here the same customer ID has some other order date, as you can see over. So one customer can purchase multiple products, and one product can be purchased by multiple customers. So this is a many to many relationship, and it depends upon the type of data you are handling. Another example, Joe Smith. Okay, so his ID is 101 and he owns how many cars? So Joe Smith, you can see his ID 101 is there, 1 and 3. So Joe Smith owns two cars, Ford and Ford Taurus and Ford Focus, right? Similarly, Bill Jones, he owns how many cars? Only one car, that is Ford Escort. 103, Sam Price, okay, sorry. 102, Bill Jones owns another car, that is Ford Focus. So he owns Ford Escort also and Ford Focus also. So here, this is what it is to say, that one person can own multiple cars, and the same car can be owned by multiple people. Like Ford, you can see here, Ford Focus is owned by Joe Smith also, and by Sam Price also. And same way, Ford Taurus is owned by Joe Smith also, 101, and by 103, that is Sam Price also. So this is a many to many relationship. Another example, students, student instruments. One student can own multiple instruments, okay, and one instrument can be owned by multiple students. Like you can see over here, instrument ID. Okay, here the data is not there, but you can still just assume that the same instrument, for example, if it is a magnifying glass, okay, these students are science students, and the students are in possession of certain instruments which they use for their science experiments. So a magnifying glass is there. It is quite possible that more than one students can have the magnifying glass, right? So one student can own multiple instruments, different instruments, magnifying glass also, vernier calipers also. And for example, if I take the case of Joe, okay, Joe Rosales. So Joe can own a magnifying glass also, a vernier calipers also, and a prism also, right? And a prism can be owned by Joe Rosales also, Zachary also, and Angie also. So this is what one instrument can be owned by multiple people, and once one person can own multiple instruments. So this is many to many relationship. Another example, classes and students. Very easy. One class can have multiple students, and one student can be taking multiple class. Students, here the idea of class is not the same idea of class which you are attending. For us, we use this word class very wrongly, students. Okay, class is not the room. We usually confuse class with the room where we are taking the lecture, but that is not the case actually. Okay, it is not the room. Class का मतलब है which subject you are taking, because it happens in other countries. Like right now, what you people, those who are coming for offline classes, what you do, uh, you might have seen, or you already are practicing, you are going to the classroom where your teacher is teaching, right? Currently you are doing that. But in other countries, this is the only thing which happens. There are various rooms, like the science teacher, the chemistry teacher always sits in the chemistry lab. Now it lab is integrated into the classroom. There they have a separate lab, not a doubt, where students, all the students have to do the practicals, but the classroom, that room of the teacher is all the, or we can say the chemistry room is, it's not any class, it is chemistry room, chemistry class. They say chemistry class, biology class, so that class will be like the half of the lab, 50% of the lab is integrated into the classroom. There are benches also. If it is a chemistry class, all the benches will have the necessary equipment for the student. Okay, if it is a biology class, all the benches will have microscopes on them, right? So it is just like that. So they, students take different classes. Like you can see the classes here: introduction to jazz, introduction to guitar, advanced guitar, jazz band. So by the name itself, it is clear that something related to music. Okay, so introduction to jazz can be taken up by multiple students, and you can see over here class ID, which all students can take up introduction to jazz. And by this connection, you can see Wayne Gentry is taking this class. Second is Zion Dean is taking this class. Third is Isa is taking the class, and last is Sally is also taking this class. So one class can be taken by multiple students, and one student can take multiple class. Like Wayne Gentry is taking introduction to jazz also, and introduction to guitar also. Same way Kathy is taking advanced guitar and jazz band, right? So one student can take multiple class, and one class can be taken by multiple students. So this is also an example of many to many relationships. I hope this relationship thing is clear to everybody. Referential integrity and relationships, that will always depend upon the table. Okay, now what we are going to see here is creating relationships, how to relate to tables. Because for any of the advanced operations like creating queries or forms or reports, we need to join two or more tables to extract data from those tables. Like, I'll give you an example. Suppose your boss asks you to display all the employees along with their department names. But here, what you see is employees are there, okay, but department number is there. Where is the department name? It is in the DPT table. So the thing is, you need to connect these two tables together. So just sit back, students, because I'm going to enter a few more data values over here, so that we are able to understand the effect of these operations. I'm going to open the department DPT table also. Only 3 departments are there, so I'll enter one more. So 120, we have 10 to 50. So now we are going to enter the data for all of them. So these are some records which I have created. Now only department number is specified here, right? What do we want? We want the employee names along with the department number, along with the department name. And department name we can get from the department table. It means I have to join the two tables together. I need to join the employee table with the department table. These two tables have to be connected to each other. And what is the common field in both the tables? It is department number. In the employee table also we have department number as the foreign key. It is the foreign key in which table? Within the employee table. And within the DEPT table it is the primary key. So now how can we connect them? So watch very carefully. First of all, you go to the tools menu. Okay. In the tools menu, you select the first option, that is relationships. So I'm going to click on this option here and it opens an entirely new dialog box over here. So currently what I'm going to do is whatever I have, I'm going to remove that. Yes. And this also I'm going to delete. So I'm going to create, normally the relationship dialog, relationship page, it looks like this. And this particular window is known as relation design window. Please make a note of it in your copy, students. It is the relation design window. And here all the relationships between all the tables as which you are defining within this current database. What is the database? Company DB. That will be displayed here. मतलब जितने टेबल्स के बीच में आप रिलेशनशिप बनाओगे वो सारे रिलेशनशिप्स आपको इस विंडो में दिखाई देंगे, राइट? So we go to tools and sorry, not tools. The moment you create such a table, okay, now I'm going to save this. What you people are going to get on your window is when you go to tools and select relationship for the first time, you will automatically get an add tables box where all the tables within your database will be displayed. Now from this table, you need to select that particular table. Okay. So I'm going to select employee and department and close. And when you add both of them, you can see that they both appear over, right? And now I'm just expanding both of them. So you can see that these two tables are there and you can see the common field DPTNO, DPTNO. So what you do is just select one of them and click and drag and drop it on your department table and you will see this kind of a relationship is formed. And it is which type? A many to one relationship. That is many departments you can find, because DEPT employee table has multiple values or duplicate values for departments. That is, one department can contain, it means one department can contain multiple employees, but it is not true the other way around. One employee can work in only one department, but one department can have multiple employees. So depending upon the data within the table, this particular relationship is formed over here. Both the tables are now connected to each other. So once this relationship is maintained, we are going to click on save. Now this relationship, you might be thinking, why did we do this? So let me tell you, it acts as a stage. It's the stage for building other objects, that is queries, forms, and reports. So when you are working on queries, forms, and reports, you will be using this particular thing, which is known as your, you will be creating, you will be working on this particular thing, which is your relationship. Okay. So relationship is a precondition before you start working on queries, forms, and reports. Now, as many tables you create, if there are related tables, that is tables containing the containing a common field, you can create their relationships here. So if you want to create more relationships, you just have to click on this button, add tables. From here, you will add the table into your table. So I'm adding the teacher table over here. Now I won't find any particular connecting table because I haven't created any other table which contains any of the, which can be connected to this. Okay. So later on, when we actually create query students, okay, at that time, we will be creating more tables. I will be having more tables in the database which are connected to each other, and those, then at that time we will create relationship. If you want to delete any relationship or any table, you can just right click on this and click on delete. It will just give a warning, so click on yes. And here also, if you want to delete relationship, you can do that. There is another button here, new relation. So if you click on new relation, this type of a box will appear. Okay, tables involved. So right now it will only show the tables which are added to this window. Okay, if you want to create more relationship based on this, you can do that, right? So we are not going into that because that is beyond the scope of the syllabus of the text. So you only had to do this. Once you are done with it, you can click Control S to save this relationship and close this window. So our relationship is created, and it has already set the stage for creating queries, forms, and reports. Now the last part of our class, students, that is simple SQL. So we have already completed two things. Now we have the last, that is simple SQL DDL commands using SQL. Now you might be thinking, what is SQL? So let me give you a brief, small introduction about SQL also. Please sit back and relax. Students, SQL is what? It is a structured query language. Okay, we have already studied databases, right? What purpose of database is there? We have already seen all those. These are all the purposes: to reduce, overcome problems like duplication, non-matching, multiple copies, data cannot be shared, not standardized, and all. And some different data models also we have seen, and we are working on the current model, that is relational model, right? So just a second, let me just skim through these. And you can see examples of common RDBMS, so many different software you can see, and this SQL word has appeared more than once at multiple places. You can see it's over here also, over here also. Okay, post GRE SQL is there, here also SQL is there, and SQL is used by Oracle also as Oracle SQL. So now what is SQL? So SQL is a structured query language. Although this particular uh, presentation is for another software, MySQL, but it's not too difficult to learn it, right? So basically, SQL is what? It is a structured query language. Please note it down very carefully. A standard language for accessing and manipulating databases. If you just note it down right now, just one sentence is there in your copy or your book, you can just make a small note of it. What is SQL? A standard language for accessing and manipulating databases. SQL commands are used to create, transform, retrieve information from RDBMS, interface between user and database, and perform multiple operations like creating tables, adding tables, records, okay, modifying data, deleting data, and so on. So all these type of operations you can perform using SQL. Although there are various classifications of
Definition
SQL,
also.
yes,
Ma'am, can you show it again?
I'll give you a, you can take a screenshot, students, of this, and you can note it down later on. It's very important. SQL is now in your course, not much is there about SQL, right? You only have to study some basic DDL commands and some basic select commands we will be doing later in the chapter. Okay.
Ma'am, now you can
Okay.
use
Thank you.
this.
Now, basically, SQL has four types. So, out of this, you are going to study only these two, DDL and DML. What is DDL? It is data definition language. You can note that down. DDL stands for data definition language, and DML stands for data manipulation language. DDL and DML. So in your first term, DDL is there. Okay. So I'm going to start with DDL, right? So pay attention very closely over. Yes. So we are going to start with creating tables. Very simple. This is the SQL command which you have to use for creating tables. And let me tell you, the data types are all those data types which you have studied already. Okay. In the previous classes, all the data types, if you remember the last hybrid class, I had explained the data types twice to you, where we have a number of integer type data, that is tiny int, small int, medium int, that is integer, and big int. And then we had studied some floating point data, that is decimal, numeric, okay. And we had also studied textual data, that is varchar, text varchar, and text fixed, that is char data type, date time data types. Okay, so we had studied all those data types. So you have to use those data types over here. So the syntax goes like this. We use create table to keywords. Okay, we use the command create table, and we provide a table name. This table name could be any name for a table, and we can provide any name, right? But without any spaces, without any spaces, without any hyphen or punctuators or any other mark other than underscore, right? And we open a bracket, and here we provide the column name along with its data type, right? So let us create a very simple table over here. So first we will see how we can create a simple table. So watch very carefully, students. Some common commands are there. I will give you a list of all those commands, so you can just go through them, run it on your computer, and based on those commands you will be able to create other commands to create other tables as well, right? So suppose I want to create a student table. I already have a student table here, so I'm going to delete that. Okay, so I want to create a student table, and it should have the following fields. First is roll number, okay, and roll number will be of this type 1, 2, 3, 4, and so on. Second is, I'll just wind up with this one thing. Second is S name, that is student name, and it could be a simple name of, that is full name of student. Third is I want the class of the student, and it should be like this way. Okay. And the last one is age. Age, we already know 16, 14, 15, 17, and so on. So sample data also you can see. Depending upon this data, can you tell me what data type should be there for roll number? Assuming that in a class, only 50 students can be there, not more than 50. So I can take tiny int as the roll number, data type for roll number, because I know that tiny int can accept values up to 127 plus 127. Okay, it will not exceed more than that. So I can take tiny int for roll number. For student name, now some student names can be very small, some can have a middle name also, so name can be very big. So here, which data type should I take?
Varchar.
Very good. We'll take text
Where?
varchar. Simple varchar. And here for varchar, you need to also provide the number of characters. So I am taking a maximum number of characters as 30, where I am assuming that nobody's name will exceed 30 characters. Even if it exceeds, database is going to accept only up to 30 characters, not more than that. Then class. Now in class you can see 12 and A, 11 and B, 9 C means it also it this type of a data is not entirely numeric. It is alphanumeric, and hence it has to be something which is related to character type data. And here you can see it could be 9C, 8C, 11P, 12A, means maximum 3 characters, up to 3 characters it can go. So we are going to take the fixed size, that is char 3. And age, again age also nobody can exceed 100 years. So here also I am going to take tiny int. Now how am I going to write the SQL for this? So watch it very carefully, students. I'm coming back here. In order to create your SQL, you have a window here, that is tools. You have a menu, and within that you have an option, that is SQL. Now within this particular window, you have to type the SQL command. Command to execute. The command will be typed here. Okay. You can check this box to show output of select statements, right? And click on execute. A list of previous commands will be displayed here. Status will be displayed here, output will be displayed here. So I'm typing the command over here. So we start with create table, and you will be seeing that how the color is changing. Student. Now, why different colors? Create table is what? Create and table, these two are the commands. So that is why their color is blue. You cannot change the name of these, right? Create table student. Student is user defined, that is we have named the table, so it is being displayed in the green color. Now first is roll number, and its data type tiny int, comma, next one student name, space, varchar, and its data type as 30, then comma, then we have class of the student, and its data type will be char, and here also I'm going to take 3. And then the last one is age, and here also I'm going to take tiny int, and close the bracket and a semicolon. So this is the command for creating a table. Now I'm going to click on execute. Command successfully executed, and now I'll close this. I want to see whether this table is created or not. So in order to do that, firstly you won't find it over here right now, so you will first save the table. Okay, you will close the current database by going to file and click on close, and then again you will open that, go to tables, and you will see the student table over. When you double click, you will be able to see only these. Okay, you need to make certain settings for the student table. So right click and click on edit. And here what you can do is you can set it as the primary key, but we will set it as the primary key using SQL in our next class. Okay, so with this we conclude today's class, students.